Hello everyone, my name is Srinivas Zabeta and today I'm here to talk about the Linux operating system as my project for CSCI 530 operating systems. Now, what is Linux? Linux is an operating system just like Mac or Windows. It is based upon Unix operating system, but Unix is a proprietary software, whereas Linux is made as an open source software. Linux has many distributions like Ubuntu, Fedora, which runs the Linux kernel. That means basically all these distributions are similar underneath the user interface. Like the kernel, the core of this operating system is same, but the flavor which is applied, the softwares and the system utilities that are on top of the kernel is different. They are developed according to the user needs. Like, for example, Fedora is more flexible for workstations and programming stuff, whereas Kali Linux is used for hacking and those kind of things, whereas Ubuntu is for multimedia and used for common people operating system, just like Windows. Now, history of Linux. Linux is built by Finnish undergraduate known as Linux Torvalds. It was built based upon the Unix operating system. First, Unix was written in mission level language, but later Dennis Ritchie, who is inventor of C, wrote the Unix operating systems, rewritten the Unix operating system in C, which helped portability and writing the high-level programs for the Unix operating system. After that, as Unix is a proprietary software, it has very high price, and the licensing process is so huge process. So there are so many companies who started to build operating systems just like Unix. So just like Unix, which resembles Unix, like in 1983, Richard Stallman started working on free software, which is based upon Unix, called GNU project. After that, FreeBSD and so many other projects have arisen due to its proprietary concerns. So many free open source projects were arisen based upon the Unix software. Meanwhile, in Finland, a Finnish undergraduate Linux Shurward who is frustrated with the Minix, which is just like Unix operating system, frustrated with the licensing process and everything else with the Minix operating system. He started off taking it as a challenge and started to build an open source Linux operating system. First, it was developed in Minix software using GNU C compiler. After that, quickly it was stable enough to develop on its own software. In 1994, first version of Linux was released. This is a history of Linux operating systems. Now, while coming to design principles, there are four major design principles for the Linux operating systems. Multi-user, multitasking system. The operating system has to be multi-user and able to multitask. And the file system and the network adapters implemented in the Unix should be able to work on the Linux too. And next principle is speed and efficiency is important goal. After the standardization of the Linux is also important. First, what are the components of the Linux? Linux has three major components: Linux kernel, system libraries, and system utilities. Kernel. Kernel, what is kernel? Kernel is a core of the operating system which has software software that tells the CPU what to do. It is an important part of the operating system, and based on this, every distribution in the Linux is built on the Linux kernel, which is same for every distribution in the Linux operating systems. Next, libraries. System libraries are the softwares. These are the softwares that implement most functionalities of the operating systems. These are shared between the users and the kernel. As these softwares doesn't need full privileges on kernel, they are kept outside the kernel. Next comes the system utilities. System utilities are the programs that manages these programs like network adapter. On boot up, the software needs to be managed. The software needs to be started on its own. Like for example, network adapters needs to be started before while booting up, and display adapters. Every adapters need to be started working on boot up. So these kinds of tasks are handled by system utilities, and there is an loadable kernel modules. Kernel modules are the piece of code that doesn't need to be inside the kernel, and which can be mounted and demounted at any time. Example of these types of codes are device managers, device drivers, etc. Now let's go. Now the major one of the important duty of the kernel is the process management. The process management, in the process management, each process is identified in two spaces. Process identified at the user space by PID, process identity, and at the kernel space, the process is identified by task underscore struct data structure, which is built into the kernel. In the user space, PID is a numerical value assigned to new process that has been started, and when the process terminates, this PID is reused and assigned to new task that is coming in. And the kernel space task struct contains every relation, every data about the information about the process, like who is its parent's process, and what are the child processes, and what is the memory, and everything about the process is dealt by task underscore struct data structure in kernel space. Each process can be in one of the 5 states in the Linux system. First is running and runnable state. When a process is ready to run or running, the process is in running state. When process is running, if you want to terminate, not terminate, when a process is running, if there are no resources available for the process to run, or there are some dependencies that need to be done before this process should run, this process goes to stop state, or like kind of wait. The signal that used to send a process to stop state is sig stop. Or you can press Ctrl Z in the terminal, which sends the process to stop state. And when the process is in stop state, it can be terminated, or it can be rerunnable, again sent to running state or runnable state with the help of sig cont. Sig cont signal, the process in the stop state will start running again. And next is the uninterruptible and interruptible sleeps. Uninterruptible sleeps means when a process is in uninterruptible sleep, there is no signal to wake up the process or to interrupt the sleep of the process. Just what we can do is only power off the system to get rid of the process. And interruptible sleep means when a signal or interrupt is raised, the process in the sleep state will come into running state. And the last one is the zombie state. When a process is stopped or terminated, it is not fully terminated, even though it releases all its resources and everything, but the ID, the process, the place of the process in the process table will not be released. So the child process will send a sig child signal to its parent's process. Now it is up to the parent process to release the child process from process table. After the state after sig child signal sent to the parent process, it is called zombie state. Now, process creation and process controlling. The process in Linux can be created by the system function and two other functions called fork and execute. Fork just creates a copy of the parent process, and execute will start the process, put the process into running state or into the queue. Sorry. And process controlling. Process controlling is done by signals. SIG HUP is a signal when a child process is running, when parent process is closed. While the child process is running, the parent process is called SIG HUP. Signal is sent. SIG INT is a signal used to interrupt the process from the terminal. SIG kill is a signal to kill the process, and SIG stop is a signal to stop the process. Memory management. The memory management in Linux system is very complex, but I'll try my best to tell you how it is done in the basic level. Every operation or every process is addressed by its virtual address by the CPU. CPU has a virtual address which is sent to TLB cache. which is sent to memory management unit. The memory management unit will check in the TLB cache whether the given virtual address is found in the TLB cache. If it is found, it is called TLB hit. So it will get the direct physical address from TLB cache and it accesses the main memory with the physical address. If there is no hit, that is TLB miss, it will go to the page table. Page table, if there is match found in the page table, it updates the TLB cache with the physical address of the given virtual address, and it is fetched from main memory. When the address is not found in TLB page table also, when the address is not found in page table, there may be two scenarios. One is when the virtual address is not a valid virtual address, which causes in another error called segmentation fault. And the other thing is the address is valid, but it is not in the main memory. So it has to fetch this data from secondary storage to the main memory. This scenario is called page fault. This is how memory management is done in the Linux system. The memory is divided, the main memory is divided into 4 stages, 4 zones by the kernel in the Linux. Zone DMA, direct memory access, is a lower 16 megabytes of the memory, and zone DMA32, lower 4 gigabytes of the memory, and zone normal, all the RAM above 4 GB in the 64-bit machines, all RAMs between 16 to 896 MB in 32-bit machines comes under zone normal memory. And zone high memory, all RAM above 896 MB exists. This type of zone exists only in 32-bit machines. Now coming to device management. Device management means how the device is interacted with the user programs. Like if you want to how an application accesses CD drive, floppy drive, Ethernet driver, all these physical components is called device management. In device management, every device makes a communication with the Linux kernel with the help of device driver. Device drivers usually are kept in files in the Linux system. For example, device driver for the CD-ROM is kept in /dev/CD-ROM file. So all the necessary information, how the communication should be established with the device and the kernel, and what protocols need to be used, and what the bitrate should be, and what type of communication is it, off duplex, full duplex. These types of details are kept in the device driver. So for example, if an application wants to read and file from the CD drive or write data to the CD drive, so it will call the device driver to set up the path. Let's say device driver in dev folder, DV folder named with CD-ROM will give the necessary information, and port is open between kernel and the hardware, like that is CD-ROM, and the communication protocols are being established, and the connection has been established, and the port is established. The application starts to write to the CD drive or read from the CD drive with the help of driver and the kernel. There are some commands to check what are the devices have been mounted to Linux system. That is ls for the file system, and lsblk for the block devices, ls PCI for the PCI devices, and ls USB for the USB devices, ls dev for all the devices. Next, coming to the file management system. The file management system in Linux has two major things, that is VFS and the external format, external to file system, ext2fs. Virtual, the first one is the virtual file system. The virtual file system is the file system that is above the single level file system, that is external ext2fs. So virtual file system is object-oriented file system. That means it is developed on the concepts of object orientation. The information about the structures of it has two components: information about the structure of the object and software to manipulate the object. VFS has four main objects, that is inode object, file object, superblock object, dentry object. Inode object is for individual files, file object is for opening the file, superblock for entire file system, dentry for the directories. The operations that are allowed on these files, on these objects, are to open, read, write, and memory map. External to file system. First, the Linux has Minix file system, which is 14-bit file system. Due to its limitation with the memory address availability, they shifted to external one file system. Due to its some of the shortcomings, they updated it to external 2 file system, which is based upon FreeBSD file system. You can see the kernel has virtual file system, and virtual file system interacts with the external file system, and external file system interacts with the hardware. Virtual file system, why to introduce virtual file system? The reason behind this is virtual file systems enables us to multitask or multiple access of the files, which is a software layer above the external to file system in the Linux. Next is the security system of the Linux. Linux by default has password authentication, access control on the file system, and security auditing. With the help of these features, they expanded those features to user group separation, file security system, audit trials, PAM authentication. User group separation means a group of users, the group of individual users are kept in under one group, like admin, user group, and owner group, student group, staff, like that. Every group separation is possible. And in the file system security, everything in the Linux system, almost everything in the Linux system is considered as a file. File has file has some privilege. Each file has some access privileges. User with these access privileges only can be able to read, write, or execute those files respectively. For example, a file with read, write, execute privileges to admin, whereas the same file can be given same file in the same file in the other groups, like staff or etc., have only read permissions. Next, the audit trials. Audit trials are audit trial is a daemon process that runs while start booting up the system. It keeps track of everything, every operation that has been done. It is internal to kernel, and it keeps track of everything that has security issues and everything. Next is the PAM authentication. Is the PAM authentication is modular. It is like adding new features to the new modules to the system for authentication purposes. Like if we want to add a fingerprint reader, if we want to add a face recognition, voice recognition, etc., that is made possible with PAM authentication. Next is a user interface. There are two types of user interface, that is command line and GUI, which is graphical user interface. Command line user interface is like text-based user interface. We have to type everything that we want to do, but it is very powerful and very fast. Graphical user interface is a graphical representation of the system, file system, and everything else, but it is a little bit slow due to extra processing that takes place to display the graphics. And there are different graphical user interfaces, for example, Genome 3, KDE, Plasma 5, XFE, XFCE, Unity, etc. What companies currently involved in this line of business? Almost all the industries, all the major industries are using Linux. For example, finance, internet, health, science, and education industries. All these industries using. In finance, New York Stock Exchange, London Exchange, all these run Linux as an operating system, because Linux can handle huge amount of data reliably when compared to the Windows operating system or any other operating system. Internet like Google, Red Hat, and every cloud-based company uses the Linux because of the same reason as the finance. It can handle very huge amount of data. Health systems like embedded systems, wearables, everything, every small embedded system, because of the flexibility of the Linux to run on multiple hardwares, regardless of this memory availability and everything else, it can run on any given hardware, almost any given hardware. This makes them suitable for embedded systems. And next is the science and education sector. The CERN and the supercomputers, everything runs on the Linux. There is no 100% of the supercomputers in the world runs the Linux because of its reliability and because of its because it is an open source, it can be modified as our needs. What is the future of Linux? Even though Linux playing major role in big companies, big sectors, there is only 5% users that run Linux on their desktops, because there are many reasons behind this. Even though it is powerful and everything else, but it is not user-friendly, whereas Windows is an user-friendly interface that can be easily learned and everything else, whereas Linux is not. And there are so many distributions, so many distributions, so many updates and everything else, which makes the user confused to use Linux. So then they need to standardize their distribution sector, even though it takes toll on innovation that has put the Linux at this position, but they need to do it because it will be chaos after a few years lying down if they don't standardize it. Conclusion. Linux is an open source software. It became very powerful due to its open source crowd who are developing and responsible for the growth of the operating system. It runs 95% of the cloud infrastructure and 95% of the mobiles and supercomputer infrastructure. Because of its growth and there need to be standardization with more rules, though it inhibits innovation to some extent. Thank you.